Okay, today, April 15, happy tax day. We're going to talk about something called the quadratic formula. Raise your hand if you've heard the phrase quadratic formula. Raise your hand if you think you could spit out the quadratic formula right now just from memory. Nobody? Usually there's a couple of people. It's got b's in it, it's got plus or minus. That's a bunch of it. That's most of it. Missing a few things. All right. So there's this quadratic formula. We'll talk about it today. I'll just put it out there right now that on the upcoming quests and tests and final exam, I will provide you with the quadratic formula. So you don't need to memorize it, but you need to be able to use it really well. All right. Given the calendar up here, I just want to point out that our next class is not until April 22, which is fully 1 week from today. This coming Friday is Staff Development Day, which means there are no classes, but the staff, the employees of GCC come in and go to meetings all day, so you don't need to come in on Friday. What's happening Monday? Patriots Day, right? Only state that gets a day off for a football team. Doesn't make any sense to me. So Monday there are no classes. So our next class is Wednesday coming up, okay? So it's going to be a little bit choppy given that we've got like a week off between now and next class. All right, so any questions on the calendar? All right. So again, starting on the top of page 156, the lesson plan actually starts on the previous day. Previous page. We're completely skipping over page 155. I just want to get you guys to the activity as quickly as we can today. So we'll start here with number 3 on page 156. Let's go to Tyler. Okay, let's pause for 1 second and refresh our memories about some of the characteristics of a parabola. How should we have known that this was going to be a happy parabola? All right, so what is positive precisely? A is positive. Remember, A is the number that's touching the x squared. It is a positive number in this case, so that is a positive happy parabola. Yeah? And you can just about guarantee that on the upcoming quest and on the upcoming test, there's going to be a problem that says graph the parabola, and you're going to go through the whole process just like last class. And the very first thing is going to say, does it open up or down, and why? And most of you are going to get the right answer. You'll say, yeah, it opens up, or yeah, it opens down, and you'll get the right answer. But many of you are going to lose a point because you're going to tell me the wrong reason for why it opens upward. This is why it opens upward, that A is positive. It's not that x squared is positive, because x squared is always positive. It's the number touching the x squared, all right? So A is positive is the reason this is opening upwards. Okay, next thing, what is the name of this point right here? That is called the vertex. In this case, is the vertex a highest point or a lowest point? It's the lowest point, but if the parabola were sad, then the vertex would be the highest point, right? Okay, and go ahead and put a dot on the 2 x-intercepts right now on that graph. Dot on each of the 2 x-intercepts. And then label those x-intercepts with their coordinates. Just read them off of the graph. We're at the top of the page, yeah. 6 and 1. Yeah, -6 and 1, with zeros in the y position, right? So those are the 2 x-intercepts. Okay, looking at that equation, let's come back over to here. If we were going to try to find the x-intercepts just from the equation, not from the picture. Picture made this a really easy problem. But just looking at that equation, what's the process we would use algebraically to find x-intercepts? We would set y equal to 0, yeah? This is what we did the other day. We would set y equal to 0. And so I have written that same equation again, but all we did was change the y into a 0. And we would solve that equation. And looking at the picture, you can predict already what the answers are going to be. What are the 2 answers to this equation, 2 solutions to the equation? -6 and 1. So this is an important connection we're making here. That the x-intercepts go hand in hand with the solutions to this equation. 0 equals, the rest of that quadratic equation. And so when you solve this quadratic equation, you would get -6 and 1, and that would have told you where to put the x-intercepts, right? So definite connection between the x-intercepts in the picture and solutions to this equation. Okay, but if we didn't have the picture in front of us, then solving this equation would involve factoring, right? And so we're not going to spend the time here. Some of you guys are very quick at factoring. Some other folks take a little bit more time. Doesn't matter how long you take, you just got to be able to get there. This would be an opportunity to use the box for some of you. But we'll go ahead and just write the answer down here. Let's see, I think it's a +6 and a -1. I think that's the factoring. So trust me on that. But if you use the box in less than 60 seconds, you would get there. And now finish solving that equation for me. What do we do with those two factors? Perfect, right? We just set them both equal to 0. Go ahead, write down those two equations that Savannah just said. And then solve those two equations for x. So what do we get? Tell me x equals. Everybody agree? So this is how we would solve this problem. You could find the x-intercepts without the picture by doing this factoring idea. Let's try to play the same game on number 4. We'll go to Ramses for number 4. All right, so let's pause there. So go ahead and, again, put a dot on each of the x-intercepts and label them with their coordinates. What do we think for the x-intercepts? What are their coordinates? You all going to say the same thing? Yeah? Approximately. Right, this one's not as nice as the previous one, right? Like I can't just pick off. All right, so just the positive one. Somebody say what their answer was. 1.5. Somebody say a different answer. 1.4. Anybody have a third answer? You guys are playing the prices right over here. So we're not going to say the same thing because we're approximating because the answers aren't as nice. And if the answers are not super nice, then it turns out the thing isn't going to factor. It turns out it is not possible to factor this x squared plus 2x minus 5. So you could use the box method and you wouldn't be able to, I think we've done this before, but maybe just a quick refresher. What does it look like when the box method fails, when it doesn't factor? Top left, we're putting x squared. Bottom right, -5. And then we go along this diagonal, right? And we get -5x squared. And then we look for factors of -5x squared, and we're hoping to find two factors that add up to what? To that 2x in the middle. That's the goal, right? And so we'll just list the factors. There's not that many. Could be -5x and +1x. And there's only one other possibility. 5x and -1x, right? Those are the only things that will multiply to that -5x squared. When you add the top one, what do we get? 4x. When we add the bottom one, -4x, right? When we add that. In either case, can we build this 2x? No. So that's how we know it doesn't factor, right? You do the box and then you get stuck. So what do we do when it doesn't factor? All right, let's try number 5. Will. Okay, so here's the quadratic formula. It says if you are solving a quadratic equation written in this particular form, and we've seen it before, ax squared plus bx plus c equals 0, that's key. It was key before for all the factoring problems. It's still key. Then the solutions are x equals, and then here's the thing, you know, this nightmare from your mathematical past, -b plus or minus square root b squared minus 4ac all over 2a, right? Ben had most of it. So that's the quadratic formula. So like I said, I'm not going to ask you to memorize it. but you got to be able to use it, and you have to be able to use it well. So let's just jump in and try using it. Maybe on the next page, we're going to solve this quadratic equation right here. 0 equals x squared plus 2x minus 5. It's the one that we just had. And we know the answers are going to be roughly 1.5 and negative, what was it, 3.5 maybe? But let's actually figure it out using that quadratic formula. So just for practice, let's go ahead and write it up here. So copy this down if you would, negative b plus or minus square root b squared minus 4ac all over 2a. So write all of that very carefully. Okay, and now we're going to follow this process here. It's not a long process. It's got 3 steps in it, but the third step is deceptively short. But the first one says, if necessary, put the equation in standard form, ax squared plus bx plus c equals 0. Is that equation in the right form? Yeah, it's descending order, 0 on one side. It's looking good. Yeah, that 0 is important. Then it says, identify and write down the values for a, b, and c. So let's read them off. A is the number touching x squared. What is it? 1. B is the number touching x. 2. C is the constant that isn't touching any x's. Negative 5. Make sure it's not just 5, it's negative 5. Any questions on grabbing A, B, and C? Okay, and so then we get to step 3. It says substitute these values into the quadratic formula and simplify your answer. So simplifying is the biggest part of this process. So let's give it a shot. So here we go. Equals. All right, this one says negative b. Negative b is what in this case? Negative 2. And we're copying a bunch of stuff. Plus or minus square root. Then it says b squared. Don't do this calculation in your head. Just write it down. B squared really means what squared? Is it negative 2 squared? Now, which one is it? Right, because we just had b out here, and it's just 2. But it's really tempting to say negative 2, because negative 2 is the first thing we wrote there. So this is just 2 squared. And then I'm copying 2 more symbols, minus 4. And then AC, and this is all multiplication, so I'm putting some dots here. So times AC, times what, times what? 1 times negative 5. And then the whole thing is divided by 2 times A, 2 times 1. Okay, my strong suggestion whenever you use the quadratic formula is to put parentheses around every single appearance of A, B, and C. I didn't do it here, but I'm going to add it in. Am I putting parentheses around the 2 or the negative 2? 2. Come on, there we go. And then over here, B, A, C. And then down here around the A. So every time I substitute, I put parentheses. This makes it really clear to me exactly what's being plugged in so that I don't make any sign errors. Okay, so let's clean this thing up. You got to know your order of operations really well in order to do this. Okay, I don't need parentheses anymore. That's just negative 2 plus or minus square root of. First thing we do in here is the square. Exponents comes before subtraction or multiplication. Yeah, PEMDAS? Okay, so 2 squared is 4. Okay, and now I'm doing a bunch of calculating kind of all at once here. I've got subtract 4 times 1 times negative 5. Ultimately, is this going to be a subtraction or an addition? It's an addition because I see 2 negative signs, right? Or a subtraction and a negative sign. So the very first thing I do is just write down what's that symbol going to be. Is it a plus or is it a minus? Because you might have like, 3 different negative signs, 2, 1. Just take care of the sign first. And then we do the multiplication. 4 times 1 times 5 is 20. I encourage you not to use your calculator for this step here. I really think that it can lead to problems. It's really easy to type it in not quite correctly. But these are not hard calculations to do by hand. Divided by, downstairs is just plain old 2. And you'll notice we follow this process. Every step of the way, the thing looks a little bit better. And that's the idea, right? This looks better than it did before. Equals. Okay, very tempting to cancel those. At some point, maybe, but not right now. They're not ready to be canceled. You see addition and subtraction. You're not ready to cancel. So let's pause on canceling that and just clean up inside the radical first. So this is -2 plus or minus square root of, that's a 24. I'll divide by 2. Yep. Okay. Now we're just going to start from this part right here, and I'm going to remind you that we spent some time in a few classes ago simplifying things that looked exactly like that. And so this was this whole separate process that you got primed to do like a week and a half ago or something like that. So the square root of 24, it seems like we can't do anything with, but the fact is there is a perfect square that goes into 24. Which one? 4 goes in. And so maybe it'll start to come back for you as we write this out. -2 plus or minus square root of 24 is really 4 times 6 divided by 2. And then we know that square roots around multiplication are nice, and so we can just take that square root of 4 outside, and what does it become? -2 plus or minus 2 square root of 6 all divided by 2. Okay, and then again, it looks like I'm ready to cancel some 2's, but what was my recommendation 2 weeks ago before we cancel anything? Remember the next step? Is to separate. We want 2 fractions. We can cancel when we have individual fractions. So we separate this guy. It becomes -2 over 2 plus or minus 2 root 6 over 2. See it? That single 2 downstairs goes underneath both numerators. And now that we have individual fractions, we are ready to cancel. And so that first fraction becomes -1 plus or minus second fraction becomes 6. Wonderful. So that is our simplified final answer. -1 plus or minus the square root of 6. Any questions on the simplifying process? Okay, so there's 2 skills that I need you to walk away from today's class with. 1 is to get to this simplified version. 2 is to be able to get me decimal approximations by typing in this kind of thing in the calculator. So if you have a scientific calculator on you, then go ahead and take it out right now. Otherwise, I'm going to loan you one. And normally I let you use your cell phones as calculators, but that is not going to help prepare you for the quest. When you don't get to use your cell phone, you have to use one of mine. All right? So grab one if you need one. Who needs one here? Do you want to use one of mine just because you won't be able to use that? All right. I want you to practice on this one today too, just because you won't be able to use that on the quest, right? Okay, here you go, Alex. All right, so let's give this a shot. Okay, everybody come back up here for just a second, and then we're going to type. Shh, here we go. This guy happened to simplify, like the denominators all disappeared, but that doesn't always happen. And so what I want us to do is go a step earlier to a place where it hasn't been cleaned up so that we know how to type it in its most complicated form. So I'm going to ask us to type in, what are we going to type in? Yeah, let's type in this guy. Let's go all the way back to this line right here. I want us to type that thing in. So there are 2 ways to do this. Maybe just circle that real quick so you know exactly which one you're typing. It's the -2 plus or minus root 24 over 2. So I've put 2 screenshots here. These are from a graphing calculator, but hopefully they'll help you with the scientific ones you have. So you can either type in the numerator by itself, -2 plus the square root of 24, hit enter, and then divide it by the 2. I think that's the safest way to go. It is possible to type it in all in one fell swoop, but you got to make sure you have extra parentheses to separate the numerator completely. Notice that this is just the plus of the plus or minus. It isn't possible on these calculators to do the plus or minus in one fell swoop, so you just do them completely separately. So go ahead and type in that thing, either the first screenshot or the second. Make sure you get 1.449, and then type in the other one. And then we'll come back together in about 60 seconds. If you're stuck, check with your neighbor and or with me. Okay, so let's move on to the next page, number 9. We're going to start this one together, and then you guys are going to finish this and then go right into the activities. So take a look at this equation right here. 2x squared plus 7/3 x equals 1. What do you think about that one? Don't like it because fractions. And you guys have been discriminating against fractions for years now. It's time to get over yourselves. Or we can just get rid of the fractions. So how about we just get rid of the fractions? What we're going to do is multiply both sides of that equation by the magical number that will get rid of the fractions, 3. If we multiply that fraction by 3, then the 3 just cancels, yeah? So let's multiply everything by 3, and we'll get rid of our fractions. So I'm copying this equation just as it is. And then I'm going to write down, okay, 3 times both sides. Did this work better for you, Lucas? Okay. On the left-hand side, go ahead and distribute that 3. Did this work for you, Alex? Good. So distribute that 3. We get a 6x squared. And then when you distribute the 3 to that fraction, the 3 just cancels. And there's a really common mistake that some folks make when they distribute here. So that comes in and we get 6x squared. That's fine. But here's the common place to make the mistake is to do 3 times 7/3 is 21/9. Multiplying the 3 times the 7 and the 3 times the 3. And if you reduce 21/9, what do you get? You get 7/3, which is kind of strange that we took 7/3, tripled it, and it didn't change. And it's because we didn't multiply correctly, right? That 3 is really 3/1. So if you're thinking of hitting everything with a 3, you're not doing what you should be doing. So if you really insist on multiplying it out, it's a 21 on top, but it stays 3 on the bottom. And then that reduces to 7. But way better is to just say, hey, we put the 3 there so we could cross it off. So it's just 7. Okay, so 6x squared plus 7x equals 3. It's looking better. It's got no fractions. It is not quadratic formula bull yet because it's got to equal 0. This is key. Cannot use the quadratic formula right here, but it's really easy to do it, and the quadratic formula isn't going to tell you it's wrong. Like you can just plug in c equals 3 and you will get some answers that aren't the right answers. So we got to make sure we get one side to 0. 6x squared plus 7x. Move that 3 over and it becomes minus 3 equals 0. So what you are going to do before jumping to the activity on the next page, and there's space for this problem on the next page, what you're going to do is solve this one with the quadratic formula, okay? So go ahead and do the quadratic formula all the way out. I actually don't know that you'll need the calculator very much for this. Do as much as you can without the calculator, I guess I'll say. And I will circle the answers. You've got them right here at the top, circled in purple. That's the goal, is to get to 1/3 and -3/2. So go through the whole quadratic formula. Maybe start by copying the entire quadratic formula just to kind of get it in your brain a little bit more. Go through the calculation, should get what's circled here, and then the activity is on the next page.